Sequences in series, geometric sequences. So today we're looking at type 3, which is finding in the unknown. And we're going to look at two different types. So the first one here is where we're going to be given the three terms. So we're told that we have three terms in a geometric sequence. And they're consecutive terms, so one after the other. And we have to find the value of x, where the sequence is x minus 2, x, and x plus 3. So the fact that it's a geometric sequence means that there is a common ratio. And to find our common ratio, we would get term 2 divided by term 1. But that must be the same as term 3 divided by term 2. In other words, this is our common ratio. So therefore, if I take term 2, which is x, and I divide it by term 1, x minus 2, that must be equal to term 3, which is x plus 3, divided by term 2, which is x. So because the left is equal to the right, that means I can now multiply across by my lowest common denominator, which would be x by x minus 2. In other words, I'm going to cross multiply. So we have x by x is equal to x plus 3 by x minus 2. So if I multiply out my brackets there, we have x squared is equal to x squared minus 2x plus 3x minus 6. So bringing everything to one side, that leaves me with x is equal to 6. So the second way we could be asked this is if we don't have the three terms. In other words, there are three unknown consecutive terms, in which case we could say that the first term in a geometric sequence is a, the second would be a times or, and the third would be a times or squared. But if we were to get the sum of these three products or the product of these three terms, it often gets quite messy. So it is easier to not say these are the first three terms, but instead is to go one prior to that. So the one prior to a would be a divided by or. Because if I multiply a over or by or, I get a. And then if I multiply a by or, I get a or. And if I continued on, I'd get a or squared, a or cubed, and so on. So for our three consecutive terms, we're going to take a over or, a, and a times or. Okay, so let's look at the way in which we could be asked this question. So we have the product of three consecutive terms in a geometric sequence is 216 and their sum is 21. And we have to find these three terms. So we start by saying let a over or, a, and a times or be the three consecutive terms. And therefore, we would say term 1, term 2, and term 3. So if we were to get the product of the three terms, well, the product means if I multiply them, I'm going to get 216. So we have a over or times a or, and that equals 216. And you can see if I multiply a by a, I get a cubed. And of course, or over or is 1. Where if we had have done a by a or squared, we would have ended up with a cubed or cubed, which becomes much more complex to work with. So you can see here by doing a over or by a times or, our ors cancel and straight away we can solve for a. So therefore if I get the cube root of both sides, a is equal to 6. So then we're told their sum is 21. So the sum of the three products is a over or plus a times or, and that equals 21. And of course we can multiply across by or, which would be a plus a or plus a or squared is equal to 21 or. And now I can put in for 6. So we have 6 plus 6 or plus 6 or squared is equal to 21 or. And therefore, if I bring everything to one side, we end up with a quadratic equation. So we have 6 or squared plus 6 or minus 21 or plus 6 is equal to 0. And therefore, that gives me 6 or squared minus 15 or plus 6 is equal to 0. And I can divide across by 3 there just to simplify it. Okay, so if we factorize this, we can say, well, what multiplies to give us 4 and adds to give us minus 5, and it must be minus 4 and minus 1. So 2 or squared minus 4 or minus or plus 2 equals 0. Take out the first 2 and get the highest common factor. So that's 2 or times or minus 2. Minus 1 is common, and or minus 2 equals 0. So we have or minus 2 times 2 or minus 1 equals 0. So therefore we have 2 or minus 2 equals 0. And then we have 2 or minus 1 is equal to 0. So that means that or must equal 2 or must equal a half. So that means we can end up with the sequence, well, when A is 6 and or is 2, then that would give me A over or. So that's 6 over 2, A, and then A times or. So therefore that sequence would be 3, 6, 12. Or if we have A is equal to 6 and or is equal to a half, then that would give me A over or, A and A times or, which gives me 12, 6 and 3. So in other words, the three consecutive numbers are the same. They're just in reverse order, depending on whether it's or is half or is 2. Okay, so on the sheet that I've given you, the worksheet, saying geometric sequences, you're going to do question, so 12, 13, 14, and 22. And then for the second one there, you're going to do the question, 3 numbers, form a geometric sequence, and if their product is 512 and their sum is 28, what are the 3 numbers? And then if you check your answer, you should get 4, 8, or 16, or 16, 8, or 4. Okay, so the next type then. So type 4 is where we're going to get the sum to n terms. So again, we've done this with arithmetic sequences, but because we're looking at a geometric sequence, we have to be careful because we're going to be using a different formula altogether when we're summing up all of the terms in a geometric sequence. Now this will be proved by induction, and therefore we'll revisit that again when revising. So we're going to look at using this formula today. So when we're getting the sum to n terms, there's 2 ways in which we can use this formula. So we have a times 1 minus or to the power of n over 1 minus or, and that's when or is going to be less than 1. So in other words, or is basically a fraction. It's a number between 1 and minus 1. Okay, so a fraction or a decimal, okay? So if we're looking at it when or is greater than 1, this is not in your tables, and that's fine because, again, it can be written, you can always use the other one. You'll just end up with the minuses cancelling out anyway, but we tend to actually use this formula when or is greater than 1. So again, A is your first term, or is your common ratio. N is the number of terms. So the position of the term. And S means the sum of. So for example, find the sum to n terms of the geometric progression 1 plus 5 plus 25. So we would say term 1, term 2, and term 3. So we can see A is term 1, which is equal to 1. And then we would need to write down what's the common ratio. So that's going to be term 2 divided by term 1. So in this case, 5 divided by 1 is 5. And then to get S of n, well, we can see that OR is greater than 1. So therefore we would write down S of n is equal to A times OR to the n minus 1 over OR minus 1. And again, if you used the formula that's in your tables on page 22, then that's fine. You'd end up with a negative number on the top and a negative number on the bottom, which would cancel out anyway. So it still works out fine. So we're getting the sum to n terms. So I'm putting in 1, 5 to the n minus 1 over 5 minus 1. And that just gives me 5 to the power of n minus 1 divided by 4. Or we could write that as a quarter times 5 to the n minus 1. So either ways is correct. So here we have find the sum to n terms of the geometric series. So again, A is term 1, which is 6. Or is 4 divided by 6, or in other words, 2 over 3. And we're looking for S of n. So this time OR is less than 1, so we would go with S of n is equal to A times 1 minus OR to the power of n over 1 minus OR. So subbing in our values, we would have sum to n terms 6 times 1 minus 2 over 3 to the power of n over 1 minus 2 over 3. And therefore we have 6 times 1 minus 2 over 3 to the power of n over 1/3. So dividing by a fraction, we're going to turn that upside down and multiply. In other words, we're going to multiply the top and the bottom by 3. And therefore that's 18 times 1 minus 2 over 3 to the power of n. So in this example, we're asked to evaluate the sum of 1.06 to the power of OR, starting at OR equals 1 and ending at OR to the power of 15. So therefore, what I essentially do is I'm going to start by writing out the first couple of terms so I can see what my first term is and my common ratio is. So in other words, we have 1.06 to the power of 1 plus 1.06 to the power of 2 plus, sorry, there should just be 1 there, 1.06 to the power of 3, and that would continue until we got to 1.06 to the power of 15. So 1.06, well, we can easily see that rather than squaring out these brackets, we'd end up with big decimal numbers, we can simply just write down, well, A is my first term is 1.06, and OR, well, I'm multiplying 1.06 by itself each time, so therefore my common ratio is also 1.06, which is greater than 1. And then it'll be the sum of the first 15 terms. So in other words, n is going to be equal to 15. So if we write out our formula, we're going to have S of n, A times OR to the n minus 1 over OR minus 1. And therefore the sum of the first 15 terms is going to be 1.06 times 1.06 to the power of 15 minus 1 all over 1.06 minus 1. So that's going to be 1.06 times 1.06 to the power of 15 minus 1 over 0.06. So putting that into our calculators and getting our answer correct to 2 decimal places gives us 24.67. So you're going to do question 5, part 3 and part 5, and you're going to do question 6 and question 14.